Series 2, we introduced exponents and radicals. So let's take a look at how exponents and radicals, how we can incorporate that with the equal sign, right? Let's say we have something starting off really simple. Let's say we have x squared is equal to 8. Now, again, we want to get, if they say solve for this, the question would be solve. Simple thing. Say, solve for this question. So to get rid of the squared, we have to take the square root of it, right? So what you end up doing, if you want to get x by itself, is take the square root of one side, and you got to take the square root of the other side. Right? Now, square root of x squared, again, this is series 2, should also equal x plus square root of something 2 or just 1. So this becomes x is equal to square root of 8. If you're going to reduce this to its lowest terms, you have to break it up into its prime terms, right? So reduce this square root of the front, so this becomes 2 square root of 2. Okay. So for this one, the answer is just going to be x is equal to 2 square root 2. Now, I'm not going to continue to go over this stuff, okay? How you reduce radicals and, exponents, if you put how you put the number here goes into the denominator. Again, if you haven't seen this stuff, and this stuff just usually is one of the main stoppers, main things that stop people from progressing on in mathematics. So if you don't know this, seriously go back in series 2 and look at that stuff and do a lot of examples, because this is, the next step up from addition and subtraction and multiplication and division. Okay. So again, if you have x squared, you want to isolate the x. You take the square root on both sides. You got to take, square root of 8 becomes 2 square root 2. So x is equal to 2 square root 2. Let's go take a look at a little bit more complicated stuff and add a radical in there as well. Okay. So we did x squared is equal to 8. We solved for that. We found out that was 2 square root 2. Let's do a radical, single radical, and see what we do to isolate the variable if we have a radical or something. Okay, the root of something. So let's say you had the cube root of 3 is equal to cube root of x is equal to 3. And again, you want to get the x by itself, right? Now, the simplest way to do this, if you're dealing with radicals, is to change them to powers, okay? To change them to an exponent. So an exponent, you grab the 3, bring it to the denominator of the power, so this just becomes x to the power of 1/3 is equal to 3, right? Now, you haven't done anything to this. You haven't reduced anything. All you've done is rewrite the radical as a power. Now, the way you get rid of this, what you need to do is do the opposite in the power, right? Now, that's 1/3. And if you want to do the opposite of 1/3, to get rid of 1/3, you multiply it by 3/1. So what you can do in the power, take this to another power. And that's another way of saying how you get rid of exponents and radicals. You're just dealing with exponents and you're doing the flip of it, the inverse of it in the power. So that's 1/3. You take this to the power of 3/1, right? So you got to take this to the power of 3/1. 1/3 times 3/1. The 3 in the top kills the 3 in the bottom. So this just becomes x. Right? And 3 to the power of 3/1 is just 3 cubed. 3 cubed is going to be 27. Okay. And that's the final answer for this one. Now, we're going to do a little bit more complicated problems with this and, start introducing, both addition and subtraction into the equation and multiplication and division. So what we're going to end up doing is working our way into harder and harder and larger problems. And, in the end, we'll end up doing what gigantic, ugly problem and, solving for the x to find out what it equals. Okay. So let's do a combination of these expressions that we've dealt with and see how we can reducing or solving larger expressions, okay, or larger problems, solving larger problems.